we discovered this formula here, right? We did an investigation, kind of like a table filling in, where we said, okay, we were given a credit card with $1,000 balance, and the credit card company, we kind of figured out how credit cards charge interest, right? We talked about how you could charge interest once a year, annually, semi-annually, quarterly, or monthly, and said monthly, this bottom row is actually how interest is calculated for a credit card. They don't just charge interest once a year, they charge interest once a month, and you have to earn interest on your interest. That's why it's called compounding. So what did we notice about, if we're going to talk about 1 year today, right? We invest $1,000 on our credit card, we don't pay it off, what's the balance after 1 year? What did we notice yesterday about these numbers? They went up the more often you took interest, right? Okay, so there's this accountant at this credit card company, and he is dastardly, he is evil, and he wants to see, okay, he notices pattern just like we did, that the more often he takes interest on your balance, the more money the credit card company gets to charge in interest, and the more money they get. So he says, okay, he sees the pattern, he's like, what if I take this a step farther? What if I don't just charge monthly? What if I charge interest weekly, daily, hourly, or minutely? Right? And the more often you charge, it seems to go up, right? So the goal is, his goal, for whatever their random number, he wants to get 1,128, right? Like you're getting there, right? You're getting to 1,128, it starts slowing down. So that's what he wants to do. He thinks if he can charge interest up to minutely, he will get there. So let's figure out these number of times interest are calculated for each of these times. So how many weeks are a year? Oh, no. 52. 52 weeks in a year. All right, how many days? 365. We're going to assume it's a non-leap year. How many hours are in a non-leap year? 8,760. Now, if you are into musicals, you will know the next one. If you have ever seen Rent, Seasons of Love, what is it? Yeah, 525,600. There's a song called Seasons of Love and Rent. And that's the first line of the song. 525,600 minutes. They go on, and they say, how do you measure a year? Then you measure in love. There's something like that in the chorus. I know that from 6th grade show part. So, we sing that in 6th grade. So, that's how often the accountant wants to take interest, is up to 525,600 times a year. So let's figure out the interest rate. Now, before we write this down, yesterday when we did this table, we said that we were charging 12% interest for the whole year. That does not change. We're still charging 12% interest. And remember yesterday we were in the table, we figured out, like, okay, if I charge interest 12 times, or 12% twice a year, what percent was that you were charging each time? 6%, right? Okay, so we're doing the same thing here. If we take interest, we have 12%, so 0.12, and I divide it by 52, it's going to be a really small number. And we're not actually going to, 0.2 divided by 52 is actually 0.002 as a decimal, which is like 0.2%. So we're not going to write those decimals down in the table because these are quite small and there's a lot of numbers. So we can just go ahead and leave our table with this fraction. That fraction is going to help us out later on anyway, so it'll just be a shortcut. All right, so we can do the same thing for daily, hourly, and minutely. We're taking this 12%, so 0.12, divided over 365 days. And same thing for hourly. We're just taking that 12% divided over 8,760 hours, or per minute. Now, where that comes from, remember yesterday we had this formula that we came up with. And that part right here, the interest rate divided by the number of compounding periods, that is that part of that formula, that R over N from yesterday. Remember doing that? Okay, so let's use that formula, and let's write an equation. We're going to break this up, so we're not going to all do it through. Yes? It is 0.12.
No, why is it not 12?
Oh, because I was doing it as a decimal. Because I was jumping ahead to doing it over as the interest rate as a decimal divided by. Because we're not, because if I could do 12%. I could do 12 divided by 52, but still I would have to write that whole decimal down in the box, and I don't want to copy that over a million times, right? So I'm making it an exact number, so 0.12, because what happens when I put it in this formula here in a minute, I would have to turn it into 0.12 anyway. Okay, I was just trying to say. Good question. All right, let's write the equations for all these, and then we're going to divide up the work a little bit. So let's review how we use our formula. So we're going to figure out the amount in our account. How much do you remember how much we invested? $1,000 times 1 plus, we took our interest rate. This is going to be this number in the box right here. Our interest rate divided by the number of compounding periods, which here is 52. And my exponent was 52 times per year, but we're only going to do the balance after 1 year today. So it'll be just 52 in the exponent, 52 times 1. All right, let's write the same kind of equation all the way down. Don't calculate it yet. Just go ahead and rewrite all these equations with the different compounding periods. All right, so you have the equations there. So all you're going to change is the denominator for whatever n is. All right, so 1 plus 0.12 over 365 to the 365 times 1 power. Same thing for hourly. I know this is a lot of little numbers to write here. Last one is especially a lot of numbers to write. Okay. So once we write those equations, let's divide up the work so we don't have to type all of that into our calculator. So pay and throw by the window. I want you to find the amount that the accountant will charge you in interest for weekly interest compounding. Then throw right here, I want you to find the daily compounding. Row and throw, hourly, and these two door rows, I want you to do the minutely compounding. And then compare with people around you. How much money will you owe the credit card company if you compound on these set intervals at 12% interest per year? Okay, so take a minute, compound, and let's see if the accountant is right. The more I take interest, it just keeps going up. Let's see, what was the last? I'll write down the last. Okay. 1126, 83. All right, so when we compounded monthly, you would have owed the credit card company $1,126.83. Hayden, yep. What did your row get? You're going to be the spokesperson. Yeah. Oh, you're still calculating?
Did we get this?
Yes. Yes? Okay. How much?
1127.34.
Okay, so it went up, right? Okay, accountant's right. It keeps going up there. You can all copy that down. Ben's row. What did you get here? Anyone? Ella? 0.47. Okay, it went up. It only went up 13 cents, but it's something. Remember, 13 cents for millions of people. Starts to add up. All right, how about hourly people? Row and throw. $1,127.50. Okay, 3 cents. It's a little bit there. Yeah, people by the door. What are you noticing? It's the same as your number. Uh-oh. You didn't get, yeah, that's not good. Flip your page. The accountant, I can't yell today, but yells, what? His tiny cold heart skips the beat. That's not what he wanted to happen. He wanted a lot of money. And it, like, think about the compounding difference here. You're going from 9,000 compounding per year, roughly, to 525. That is a ton of a difference, right? Like, that's hundreds of thousands of compounding period difference, and the amount basically stayed the same. I know there's some decimal, like, fractional pennies changes, but stayed the same. That's not cool. All right, so he is not happy about this. This is a dastardly accountant. He wants to make his money. He's like, what? There's no way to reach $1,128. It's just not happening for him. He's stuck at $1,127.50. But his thought is, what if I can charge interest even more than minutely? What would be the next thing after minutely? Secondly, and then every like half second, a quarter second. So he's even like, okay, every second is just not even good enough. What if I start charging interest all the time, an infinite number of times in a year? Okay? So this table, we're going to kind of skip it, but let me talk about what's happening here. Because we're going to use our graph. We're going to make it faster. We're not going to type all the numbers in. So in order to illustrate what would happen if we took interest, not quite an infinite number of times, but like up to like 1,000,000 times a year, we're going to use a new equation. Now it's the same idea, except instead of $1,000 to start, we're going to start with $1. Okay, so we'll have 1 as our starting point. So say you just charge $1 to your credit card. Then we're going to take interest, 1 plus. Now instead of 12% interest, we're going to like ramp it all the way up to 100% interest here. 100% interest, and we don't know the number of compounding periods. We're just going to call that x instead of n to the x power. We're going to do x times 1, so you don't have to put the times 1. But that's the equation. So we're going to use the same idea, but we're just changing the numbers so that it graphs nicely for us. And here's what I want you to do. I want you to pull out your calculators, and let's type this into our y equals. All right, I'm going to skip the table. So let's go to y equals. Let's type our fraction. 1 over x all to the x power. Now, when we hit graph here, you should hit zoom 6 in case your window is still changed from the other day. You get that funky looking graph. Now, can time, x is the number of years. Can the number of years be negative? No. So we're really only interested in this right part of the graph, correct? Are we all okay with this so far? So let's change our window so we're only looking at the right part. So let's hit window, let's all change it together. Because I'm going to tell you how to change the window. The x min, I'm going to go from 0, and let's make the x maximum 500. Okay? And the scale, let's go by 10s. Now the y minimum, we're going to go from 0 to 5. And just go by 1s. And then you can hit graph. That's what we're focusing in on. Okay. Now, here's what I want you to do. We're going to trace this graph. Because what the table was going to have you do is say, okay, what happens if I took interest 10 times up to 1,000,000 times? So what if the x value went from 10 to like 1,000,000? So let's just use our calculator. I want everyone to hit trace, not second trace, just trace. You're going to get a cursor on your calculator. Now that cursor, you can move it left and right and see the x value changes and the y value changes. I want you to keep going to the right. Just keep going to the right here. What happens to that y value? Very slowly. Kind of, not really. What number do you think it's getting close to? Like, estimate it for me. If you kept going, like roughly it's 2.1. 2.71 something, right? Okay, so just keep that in the back of your mind, 2.71. Now, that's where my graph is getting to. That graph is illustrating something called a limit. All right, in this problem, there's a limit to how much money this accountant can get from you. You can't get infinite amount of money no matter how many times you take interest, unlike what the stats of the accountant wants. Now, limit is a calculus subject, and it's kind of fancy. We'll talk about it in pre-calc next year, and that's actually how you'll start calculus when you take it and starting talking about limits. A limit, I'm not going to go into the formal stuff, but what this number, this is a special number that we approximated there, what this says is as x goes to infinity, so basically as we keep going to the right on my calculator here, the y values approach the number e. Oh, and e, let's approximate e here. Take our calculator. Let me show you where e is on your calculator. If you hit the second button, And then look on the right. Do you see where E is on the right screen? It's in little blue, a little blue letter. What key is it? Division. If you hit that and then hit enter, does that look like the number? Kind of like the number we were getting close to? Yeah, 2.718 is roughly what E is here. That is what E is. So E is an irrational number. It's a new number for you. E is the number. It's kind of like pi. It's a decimal that goes on forever. You know, like you've heard people celebrate Pi Day. In high school, we decided E needed some love, so our math teacher let us. I had the same math teacher 3 times. She let us celebrate E Day in February. So we had to bring in E, things that started with E, like candy eggs and eclairs.
You should do that.
We can do that if you want. Remind me in February.
What day is it?
February 7th. Now, what would have been really good would be 2 years. Last year would have been February 7th, 2018. 2018, but we missed it. We'll do it 2000.
It would be 2 years ago.
Yeah, 2 years ago. You're right. All right, so here's what we did our graph. Okay, so the reason we're doing E is, does that kind of make sense? Like from our table, that there's a limit to how much interest this accountant can make. All right, now, so even if you charged interest infinitely, you won't make infinite dollars. So we come up with this new formula, which I'll show you in a minute, to talk about continuous growth. So not everything can be compounded minutely, or secondly, like credit cards are charged monthly. So things that might use infinite growth, continuous growth, would be something like the half-life, like carbon dating. Do you know what carbon dating is? All right, so the half-life of carbon is how you can tell how old a fossil is, because you know how much carbon is in, and they know how fast carbon decays. Carbon decays continuously. Same with like the growth of the human body. Like you don't just grow like your body, as your kids, you only grow like on Mondays. You don't just get taller on Mondays, right? You're like constantly getting a little bigger. Are babies only born on Tuesdays? No. Oh, they're not. Babies are born on every day of the week, all times of the day. These are continuous growth. So we have this new formula, flip the page, to represent the continuous growth. The PERT formula. Have you ever heard of the PERT shampoo? That's like old people shampoo. Yeah, PERT. I think my grandma uses PERT. PERT is the formula. So basically what it is, it's very similar to the compound interest formula we did yesterday, but this one, that E replaces this part of the formula. So we're going to use the formula with the pink stuff. If they tell you how often you take interest, quarterly, monthly, weekly, but if they just say you take interest continuously, we're going to use E because of that limit thing that we just kind of saw. Okay? So let's just see one, because I want to show you one more place where E is on your calculator, and then I'll give you time to work. All right, so suppose you deposit $1,000 into a college fund that pays 1.2% interest compounded continuously. This is your key word here to use this new formula, continuously. What's the balance after 5 years? So let's set it up. What is the principal in your account? 1,000. Now again, since it's continuously, I'm just going to put E. E is not a variable, E is a number. And then what is my interest rate here as a decimal? 0.012. So I'm going to use 0.012 and then times 5 in my exponent. Do not take the time to figure out what 0.012 times 5 is. Let your calculator do all the math for you. So when you're in your calculator here, I'm going to show you 2 places where E is. So the first one here, we're just going to use the same E we did before. You'll hit the caret, 0.012 times 5, and you should get that number. Did anyone not get that number? Now, if you are a person whose calculator does not make the little exponent here, and it just does a caret symbol, you need to put 0.012 times 5 in parentheses. Okay? Here's one more spot where E is. So type 1,000 again. If I hit second one more time, on the left-hand side here, do you see an E? Yeah, it's right over this button called LN. We're going to learn what that LN button is next week. That's called a natural log. But when you hit that one, that just automatically gives you the exponent box. Okay? So it's the same thing, and you'll get the same answer. It saves you half a second of work. Okay? We got it? Do you understand? So I want you, on the next page here,